We're all familiar with statistics from different contexts, often in media, for example. We study, for example, how many people have voted on a certain party in an election, or how the points vary according to an exam in mathematics, or the carbon dioxide levels in the atmosphere, how it changes with time, and so on. And statistics is teaching methods to gather and work with and describe and draw conclusions of this kind of data. So we start with some statistical material. We start with the data set. So we have a number of data. So here we have a data. So for example, this is the data we have gathered in observation 1. This is the data we observed in observation 2, and so on. Each of these data belong to a certain data type. And we will call the data types U1, U2, up to UN. So for example, so if we throw a die 10 times. Then we will have 10 results. For example, we get 6, 4, 3, 3, 1, 6, 2, 4. How many do we have now? 8, 9, and 10. So we have 10 data. So this is x1, x2, and this is x10. So we have 10 data in the data set. And the data types here are the different results we can get. So data type number 1 is getting a 1 on the die. Data type 2 is getting a 2 on the die. And the last data type is getting a 6. So we have 6 data types. So m equals to 6. If you have a data, it can be numerical or non-numerical. For example, in the example we just had, the data was numerical because we could get 1, 2, 3, 4, 5, or 6. But if we could also have, for example, getting colors, or if it's an election, they have voted yes or no. So the data could also be other things than numbers. But often we will study numerical data. And then we talk about discrete data and continuous data. So this is an example where we have numerical data. So we have these two types. So discrete data means you have, for example, a number of things. How many apples do we have? We can have 0, 1, 2, and so on. So we have discrete numbers. We don't have numbers in between 0 and 1 and between 1 and 2. But continuous data, we have intervals. We could, for example, have all numbers between 0 and 2. So if you have the number line here, discrete data means just particular points on the data line. While if you have continuous data, we have intervals. We could have any numbers in an interval. So they are discrete data and continuous data. So let us look at frequency. What does that mean when it comes to statistics? So frequency of data, we will write it as F. So that's the number of each data type we have in the data set. So if you have, for example, thrown a dice 5 times, so we have gotten a 1 and a 4 and a 1 and a 3 and a 1. So frequency of 1 here means so many times I have gotten data type 1, and I have gotten data type 1 3 times. And data type 2 I've gotten 0 times because there is no 0 in the data. And data type, frequency of data type 3 I gotten once, and so on. So these are the frequency, how many times I have gotten each data in the data set. Then we also can talk about relative frequency. And what is relative frequency? Yeah, if I have a data set, let's take a throw a die again. So I got a 2, 1, 5, and a 1, and 3. So what is the frequency of 1 here, for example? Yeah, it's 2, since I got a 1 2 times. What is the relative frequency of 1? Yeah, per definition, the relative frequency is so many times I've gotten 1, that is the frequency of 1, divided by the total number of data in the data set. And here, the total number of data in the data set is 5, since n equals 5. So this is equal to 2/5, so 0.4, or if you like, 40%. So the relative frequency of ones in the data set is 40%. That means that 40% of the data in the data set are ones. So more generally, relative frequency of a data type U is the frequency of U divided by the number of data in the data set. And often it's natural to give this in percent, but you could just as well answer it in decimal number or in a fraction. So let's take an example of this. So let's say that we have a statistical material, that we have an exam in math, and the 20 pupils has gotten their grades, and they have gotten grades in the letters A, C, E, B. These are of course just random letters I'm writing here now, but some characters for a class. How many do I have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 5 more. Okay, so now we want to figure out the frequency of grade A. How many 8s do we have? Yeah, 3. And then we can calculate the frequency for all our data types. The data types here are A, B, C, D, E, F. So for example, the last frequency, F of F. How many F's do we have in the data set? 2. And then we can also calculate the relative frequencies. What is the relative frequency of grade A? 1, 2, 3. Yeah, we could also look here. We had 3. So it's the frequency. We have 3 out of a total of 20. So yeah, we could answer this in as a fraction. But if we want to do percent, this is 1500. So 15%. So 15% of the data are grade A. Then we can do similar for all the grades, but let's just do the last one. So relative frequency of grade F, let's look at here, they had 2 F's out of 20. So this is just 10%. So this is how you can calculate frequency and relative frequency of a data set.